Okay, it says copy the diagram shown and extend each ray. Classify each angle as right, acute, or obtuse. Then use a protractor to measure the angle to the nearest degree. Okay. So let's start with GFK. When it says GFK, I read it as G2F 2K, and the middle letter is always the vertex. It's always that point that it comes to.
Okay.
So GFK, I mean, we actually can do better than like what they do here. I can actually grab it. I can paste it here, and I can show you that I'm sorry, I didn't quite grab it all. Let me try that one more time here. I can actually snip the whole thing, but let me just draw it out differently. So it's G to F to K. Here's G, here's F, and here's K. Is that okay so far? Let me know, Julia, if you're following me or not.
Okay, it's
Are we having a connection issue?
yeah, I think so.
Okay, so the G to F to K is here. I am recording this lesson, although that won't help you very much if you need it tomorrow, because it takes like a day to get to finished recording and then process. But I will get you access to this eventually. There's three options here: right, acute, or obtuse. So a right angle is 90 degrees. It's also this symbol right here. So this is a right angle, and its measure is 90 degrees. So that's for number 30. I'm concerned that either you're not following or there's a disconnect. You're not in the room anymore. Okay. That's not good. Hey, Julia.
I
see you're back in the room.
Yeah.
Okay. Where I left off is I was trying to show you this angle, this G to F to K, and it's a right angle because it has this box next to it.
Yeah.
And then it's 90 degrees.
Okay.
So we're going to look at 32 next. 32. And 32 says L, it's angle LFK, which I read as L2F2K. Okay, so that's this one kind of up in this region up here. It's L to F to K.
Okay.
L to F to K. And you could, I'm not going to draw the other one, but if I do it as a dotted line here, this is a 90-degree angle, this dotted line, this right angle here. Like if I get these two squares, this makes a 90-degree angle. So this angle, this L to F to K, this thing that I'm drawing in here, this right here is less than 90 degrees. So that's called an acute angle. That's the definition of an acute angle. It's less than 90 degrees. So the thing that's challenging here is the instructor wants you to get your compass out. They used to get your compass out and protractor. And the compass is used to draw the angles. Protractor is used to measure them, and they want you to measure the angle. Do you have a protractor?
I don't.
You don't. Okay. I don't either, so we're kind of in the same spot here. I'm going to say that it's kind of this, it's sort of halfway between, so I'm going to estimate it's about 45 degrees.
Okay.
Sorry, I went by it here. So this is about 45 degrees. Okay. Now I did skip a 31. These are odds, so I'm assuming they're in the back of the book. If that's okay with you, I'd like to go to 34.
Okay.
So that's G to F to H. So 34 is GFH angle. I read that as G to F to
Yep.
H. And I am going to copy this one again because it's just well, I sort of have it here. Let me do a new. So this G to F to H is this part G to F to H. So we got G here, F here, and H here. So if I draw this line here where that K is, that's 90 degrees. This angle right here is a little more than 90 degrees. So the whole angle here is 90 plus some amount. We'll call it maybe 45 degrees. And that's a total of 135 degrees. So if the angle is more than 90, it's considered to be obtuse. So there's three possibilities. There's acute is when the angle is less than 90. Sometimes it's drawn like this. Right
Mm-hmm.
angle is when it's equal to 90. It's also that sort of, got that symbol there. And obtuse is when it's greater than 90.
Mm-hmm.
Right. Do you need to, do you have access to the back of the book to see what 31, 33, and 35 are? If you wanted to do those on your own.
Yeah, I do.
Okay. We can always come back, but let's see what else you want to work on here. Give
Okay.
me kind of your next direction here for homework here.
If we could just do the rest of if we could do 36 to 41, please.
36 to
Or
41.
36
Okay.
to 40, basically.
Okay. So we're going to finish off your 36 to 40. All right. I am going to copy in 36. Okay. And we're going to get a little more room here. And we're going to paste this question in, make it a little bigger, easier to see. All right. Okay, it says here, let me actually have to scroll this a little bit. Okay, I can't quite get it to fit in the window I want. Okay, determine at least 3 different times during the day when the hands on a clock form each of the following angles. Okay, so a right angle, obtuse angle, and congruent acute angles. That last one I might have to look up. That doesn't sound standard to me, but so what it's saying in terms of um, right angles, you're looking for somewhere where like the large hand is pointing up and the little hand is pointing either right or to the
Mm-hmm.
left. So they give you a clock there because we don't even look at
Okay.
these things anymore. But part A at
Mm-hmm.
3 p.m. or 3 a.m. for that matter, because we don't know whether it is, that's when the clock is pointing up and to the right. Is that okay?
Yeah.
Now, how about because it says 3 different times. What's another time that you might see?
9 a.m. or 9 p.m.
Yeah, exactly. So we can also say 9 p.m. or 9 a.m. So an obtuse angle, there's lots of possibilities for an obtuse angle.
Mm-hmm.
It actually could happen at really at any hour or time of the day. You just need a situation where that large hand is more than 90 degrees away from the little hand. So I can't believe we're even drawing this, but let's just say the hour hand is pointing. Um, let's say the hour hand is pointing, or the minute hand. I'm sorry, the minute hand is pointing to the 9, and
Mm-hmm.
the minute hand is pointing to I don't know, somewhere just past the 3. So this is 3:45 because it's the hour hand here, which is a little shorter. Let's draw that a little shorter. It's just past the 3. The angle has to be more than 90. This is 90 right here.
Mm-hmm.
So that's like one possibility. I mean, you frankly could say 3:45, 3:46, 3:47. But the point is you're spreading them apart to in such a way where you see that they're not 90 degrees. So what's
Mm-hmm.
interesting, I mean, I guess what's kind of interesting, I think this is actually a good test question because you do have to actually know how a clock moves. Right at 3 o'clock, you do have this, but a little bit later on, well, this hand isn't moving as fast as this hand, so you could actually go a little bit before 3 o'clock. So like I said here, like
Mm-hmm.
2:45, for example, would also be a good one where it's actually pointing a little bit up here towards the 2, and then this is back here. Um, so there's actually a lot of answers here, and there's not I don't know, there's not like a good I don't know. Maybe they're looking for something simpler, but probably what they are. I'm probably overcomplicating this. Like at 4 o'clock, the hour hand minute hand's pointing there, and the hour hand is pointing there, and the minute hand is pointing there at 4 p.m. So that's a possibility. Same thing with like 5 o'clock. That's probably what they wanted, where the minute
Mm-hmm.
hand is there, and then the hour hand is pointing there at 5 p.m. They probably didn't.
Yeah. Yeah.
Okay, so the this last part where it's asking for what does it say here? Congruent acute angles. I'm not quite sure what your book is exactly referring to there. Congruent acute angles. Um, one of the answers that I'm seeing with an online reference is like 2 o'clock. Um, so
Mm-hmm.
I'm not quite sure. I'm not quite sure what to say other than it does look like it works at um, other than at 2 o'clock. So maybe check that with your instructor. Um, I think there's quite a few more, but that's the best I've got for that one.
Mm-hmm.
So let's move to 38. So 38 refers to a figure on the right. Let me copy that in. Okay, in the figure, BA, the figure BA and BC are opposite rays. So
Mm-hmm.
you can see that BA goes to the right, or I'm sorry, to the left, and BC goes to the right.
Yes.
So that's what it means by opposite rays. BH bisects angle E to B to C. BH bisects angle E to B to C. Okay, so that means that this angle and this second angle I'm about to draw, they're the same. So sometimes books use 2 lines to show that, denote that. Is that okay? Is that clear what that means? So
Sorry, what?
E,
It's lagging.
E to B to C. Okay, that's the angle here, E to B to C. So that's, I'm going to draw it here. That's E to B to C. Okay, and then there's this angle, this ray BH. So this BH, it bisects this angle, meaning these two angles are equivalent to one another. So that's why I've drawn these two double lines between them.
Mm-hmm.
So that probably is useful. So we're going to look at 38. And it says if EBH is 6x plus 12, so that's 6x plus 12. And it says that H to B to C is 8x minus 10. Find the measure of E to B to H. Okay. So these angles are congruent, and these two algebra expressions are defining those angles. So we're saying that angle EBH is equal to angle HBC. And then we're given that 6x plus 12 is EBH and 8x minus 10 is HBC. So
Mm-hmm.
this is what's down here below it. This is 8x minus 10. So now we just have to solve for x. Okay, so this is why you had your previous classes. I'm going to add 10 to both sides. So we have 6x plus 22 equals 8x. I'm going to subtract 6x from both sides. And I get 22 equals 2x. Divide both sides by 2. And then we get x equals 11. This is a very common example of an intermediate result
Mm-hmm.
that is not what they're looking for. So geometry, much more so than algebra, has a lot of these where you find x, but sometimes it asks for x. It says, sometimes the question actually says, what is the value of x? Here, though, it's not asking for x. It wants the measure of angle EBH. And we know that that is 6x plus 12. So we're going to substitute x equals 11 in for x. So it's going to be 6 times 11 plus 12. So that's 66 plus 12, that's 78 degrees. Always let me know if there's something that you would like me to clarify or explain again on this. So I guess we'll go to 40. Is that
I
okay
have a
for you?
quick question.
Yeah.
It kicks me out for like the after we found that x equaled 11. Can you explain the next part? Sorry.
No problem. So after you find that x equals 11, after you get that value, you have to remember what is the problem actually asking for. And it's actually asking for the value of the angle. Like it says, find the measure of this angle, E to B to H.
Mm-hmm.
So that the measure of that angle is 6x plus 12.
Mm-hmm.
It's 6x plus 12, but we have a value for x, 11, so we're going to substitute that in, and then we're going to simplify. So the point is, so in this problem, the big picture is they tell you that the two angles are equal. They give you expressions for each of those angles, and you set them equal. By setting them equal, you can find the value of x. By finding the value of x, you can put it back in to the other equation. It's very similar to like solving a system of equations where you set them equal and then you find one value and then you use it to find the other.
Mm-hmm. Okay. Thank you.
We should do, well, we should do 37.
Okay.
So 37 says measure of angle ABE, and it gives you the measure of angle EBF. ABE, and if we look at the picture, let me snip the picture in here. It's telling you that the measure of ABE is 2n plus 7, and it's telling you that the measure of angle EBF is 4n minus 13. Do you see that?
Mm-hmm.
The picture says that A to B to E, we don't know what it is, but it's shown there. And then E to B to F, E to B to F is this other one. But you see how there's these two red lines there that I'm now covering up
Mm-hmm.
in your book? That means they're the same. These are the same. The measure of angle ABE is equal to the measure of angle EBF. They're exactly the same. So we take what they're equal to, 2n plus 7, and we set that equal to 4n minus 13. Is that okay? Your brother had some issues over the summer with the connection. I mean, if there's an issue on my end, I would definitely like to fix it. I'm concerned you're not hearing me or seeing most of this.
I keep getting kicked out just a little bit, but I'm fine.
Okay. So we found that the two angles are equal, so we set the expressions for them equal, and then you would solve for n. So there's kind of two principles, guiding principles here that you will want to think about when you're taking the quiz. The one is you oftentimes set things setting them equal.
Mm-hmm.
Okay, and then the second is usually that they add up to something. So let's take a look at 40. 40 says E to B to C, okay, is equal to 31A minus 2, and E to B to H is 4A plus 45, E to B to H. Find the measure of angle H to B to C. Okay. So we'll have to copy in the picture again. You end up doing a lot of copying in this. Let me copy that one more time here. So we're gonna do 40 here. All right, so it's saying, the book says in 40, E to B to C, E to B to C. So this whole thing here is 31A minus 2. And E to B to H is 4A plus 45. E to B to H. So this one right here, that one, okay, is 4A plus 45. And we want to find the measure of H to B to C. So we're trying to find this sort of this Y here.
Mm-hmm.
Measure of E to B to C. And we know that, what was the second one there? Sorry, I'm losing track because I'm looking at two screens. E to B to C, the whole thing is 31A minus 2. E to B to H is 4a plus 45. Find the measure of angle HBC. So HBC is this y here. So what it's saying is that you've got sort of this big one, that's the E to B to C. You have this little one here, that's the 4a plus 45, and they want this one that I'm drawing here. So we know that y plus the little one, 4a plus 45, has to equal 31a minus 2.
Okay.
We know that it's like piece 1 plus piece 2 equals the total. Now, what's concerning to me is I can't decide if, and you could probably help me if you look back at example 3, if you're supposed to reuse numbers from like the previous problems, or if they want you to just find this in terms of or if they want you to actually find the value of A. I think they probably do, but I just wanted to know that as well. Do you know?
I'm sorry, what are you asking?
If see how it says example 3 on the left, that tells you, like, if you go back and look at example 3, if it is a like if they're actually finding the values for all the problems.
Example 3. No, it's different. Is that what you're asking?
Well, I'm trying to ask if they find the numbers, if the answer gives you numbers to this.
Yes.
Okay. You're in chapter 1, is that right? What section are you in?
Right now we're in lesson 1-4.
1-4. And we're doing, this was question 38 or 40?
I think it was 40.
40. Okay. Okay. So the thing that is, I guess the thing that I guess it because this picture is the same each time. So this right here, this right here is the same as the y. That's one of our givens. So instead of calling it y, you can call it 4a plus 45. So it's this part plus this part adds up to the whole thing. So that means once you set the equations together, you can then solve for it. That's supposedly the easy part. So again, the first problem we did, number 38, you set them equal. In 30 and 40, you set them to add up to something. In this case, they added up. It was like part 1 plus part 2 equals the whole, or the total. So from this point, you're just solving. You combine like terms here. That's 8a plus 90 equals 31a minus 2. Subtract 8a from both sides. Add 2 to both sides. So you end up getting 92 on the left equals 23a. When you divide by 23, you get a equals 4. But again, like the previous problem, it's not asking for the value of a, it's asking for the measure of angle HBC. And HBC is what I was calling y for a while, but it's this 4a plus 45. It's 4 times 4 plus 45, 16 plus 45. So that's 61 degrees. Should we do 39?
Number 39.
Yeah, should we do that? Do you think that would be helpful? I didn't hear you.
Are we doing 39, correct?
I'm asking if you want to do it. If you want me to do it.
Sure.
Okay, so in 39, it's looking at angle measure ABE, or I'm sorry, ABF and ABE. So it's looking at ABE, ABE, and it's looking at EBF, EBF. And we know that these are the same. So it gives you the total this time. ABF, angle ABF is the total. You can think of it that way. And ABE, angle ABE, is the part. But there's two parts. There's this EBF, which is a second part. So it's measure of angle ABE, okay, that's this one, plus the measure of angle EBF equals the measure of angle ABF. So they give you ABE is 2N, or I'm sorry, 2B, and they tell you that ABF is 7B minus 24. So it often feels like you're missing something. You're not missing anything though. You are supposed to recognize that these are the same. So this is also 2B because they're the same angle. So it's very common in these problems to use one of the expressions twice. So this is 4B equals 7B minus 24. If you add 24 to both sides, you get 24 plus 4B equals 7B. Subtract 4B. That gives you 24 equals 3B. Divide both sides by 3, and you get B equals to 8. But again, like all the other problems, it doesn't want the value B. It wants the measure of angle EBF. EBF is the same as ABE, which is 2B. So that's 2 times 8, which is 16 degrees. Okay, you had mentioned that you emailed me some questions, maybe part of your so I'm seeing an email here, but what questions do you want to work on from this email?
From the email, let me see. If we could do the first picture.
Okay, so the first picture, to me, that shows, it says use the figure at the right is the example 1, and then practice and problem solving, it says for exercises 12 through 29, use the figure at the right. Is that what you want to work on?
Yes, that'd be great.
Okay. Let me copy it in. Okay, is this correct? Is this what you were expecting to see?
Yes.
Okay, it says name the vertex of each angle for number 12. So angle 4 is right there. I just circled it, angle 4. And you can see that it's on the inside. So the vertex is where the two sides come together. So it's point Q is the vertex. For
Okay.
for 14, angle 2, I got to find it. It's right there. It shares a vertex with a couple other angles. It's that R, angle 2. It's point R because it's where the two sides. You think of it was where two sides come together.
Okay.
To form a point. All right, so should we move to 16?
Yeah.
Okay, so it says name the sides of each angle. Angle T is up here, to P, to Q. Okay, so it's I guess, I don't know how helpful this ever is, but it's this one right here,
Mm-hmm.
that one. And what I see for number 16, what I see is that there are these sides PT with a single line above it, comma, PQ. So PT is this, I don't know, this orientation, and then PQ is down here.
Mm-hmm.
Angle 6. So angle 6 is pointing, it's on the inside, it's in the interior of this. Let me grab some color here again. I think that could help with this. So there's, for angle 6. So what I'm seeing for number 18 is that angle 6 has sides N to M. Usually you start at the vertex
Mm-hmm.
and go out, and then NR with a single line. These are line segments, actually, is the correct reference to them. All right, let's look at 20. Okay, so angle 9 says write another name for angle 9. So when I'm looking at 9, it's sort of down here in the lower left. I'm going to give you all the options for that so you can see them. Angle S to R to M is an option. It's also an option to say M to R to S. Those are the only two options. Do you see how the first and the third letters are just switched?
Mm-hmm.
That is just depending on where you think you want to start the angle. But the vertex is always in the middle. R is always in the middle.
Mm-hmm.
Let's look at 22. 22 is angle MQS. MQS. So it starts, see if I can make sure it's clear. So M starts way up high here, goes down to Q, all the way to the left to S. So another angle for that is angle 4.
Mm-hmm.
So you could say angle 4. You could also go R to Q to P. You could also do them in reverse. You could go angle P to Q to R. You could also use the S. You could also say like S to Q to P. But notice each time the Q is in the middle, except when it has a single number associated with it.
Mm-hmm.
Okay, what else? I mean, I want to just go a little bit longer with you because we started a little late and we're getting questions figured out. Like, is there something else that I can help with tonight that would be useful for you before you take your quiz?
Okay, so the second one that I sent you over text, it's like a and then a coin.
I'm looking. Okay, a pin and then a coin. Yes.
Mhm.
Which questions? Which numbers on that? I see it starts at 14. Is that
Um, if we could do like um just a few of those, maybe like 2 or 3, and then
starting at which number? 12, 13, 14. Where do you want to start?
can we start at 13? Actually, no. Can we start at 14? Sorry.
Yes. Okay, now I understand what you want to look at, and I'm going to copy it in to here. It's going to be a little bit challenging for you to get tested on this stuff, but I assume that they're going to give you some flexibility because they like sometimes they're asking you to use rulers, and we already saw that with the protractor earlier. 14 here, it wants you to find the measure of segment EF. EF is the whole distance.
Mm-hmm.
Okay, so EF is equal to EG plus GF. And we know that those values are 2.5 plus 2.8, which is 5.3 inches.
Oh, okay.
It's 14 there. Let's try 16. 16. So 16, PR is what you're trying to find, and PR is the short segment. You know that PR plus RS equals the whole thing, PS. And do you see that you're given the value of RS? RS is 3.7,
Mm-hmm.
and PS is 5.8. And we don't know PR, so we can just leave it as is. To solve, you're going to subtract 3.7 from both sides, and you're going to get PR equals 2.1.
Okay.
Let's do one more since I've already got the picture up. I'll do 18 here. So it wants you to find WY. WY is equal to YX. They're congruent. That's what these vertical lines mean. They're congruent. So WY, which is a line segment, plus YX, which is also a line segment, equals WX, which is also a line segment. So we know the total is 8.8. We don't know either of these, but we know that they're the same. So we can say like X plus X, or 2X, equals 8.8.
Mm-hmm.
We know that X, when you divide by 2, is 4.4 millimeters. I don't know if I put units in this last one, PR. I did not. Looks like it's millimeters. All right, let me, if you could just give me enough time to show you a few things that I think will be very helpful
Okay.
to you. I made a lot of changes, but I mean, it's all to help help you as a student. So you already booked through my website. Thanks for doing that. It's just a lot easier today. The reason
Mm-hmm.
the email didn't go to you is there was an error in the email. You had a typo in it, and then there was
Oh,
also an
okay.
issue on my end, but it's been resolved. You know about private tutoring.
Mm-hmm.
You already did that, but the reason I'm showing you this is not for that. I wish the page would load faster. I'm doing a virtual homework help class. It's totally free. I'm doing it on Mondays at 7 and Wednesdays at 4.
Oh, okay.
So it's an opportunity to get a quick homework question answered, and I'd actually really appreciate you taking the time to do it.
Yeah.
And then I post all my video lessons here. I've got a YouTube channel. None of your information is ever there, but it's a great way to promote my brand, and it's a great way for you to see the lessons. So this
Mm-hmm.
will be posted in the next day. It might be Sunday before it gets posted, but
Okay.
it'll you'll know it because you'll remember what we were working on.
Yeah.
That's all I've got to say. Is there anything else that I can help you with today?
Um, I don't think so. I think that's pretty much it.
Great. Well, I appreciate you scheduling, and I'll see you next time.
Wait, actually, I think I do have a question.
Okay.
I'm going to send you a picture. Okay, I sent it to you on text, and it should have already sent. Oh, it's sending right now.
Okay. All right. Which problem? I can only probably do one or two. Which one do you want us to look at?
Could we do example 4?
Yes. Okay. How many planes are shown in the given figure? So a plane is a flat surface. So if you were to look at a box, I know this isn't a box, but if you were to look at a box, it has 6 planes because there's 6 flat surfaces. So what you've shown me on the right is a triangle on the front. There's a triangle on the back, front, back, and then there's the sort of the right side of the tent. There's the back side of the tent, and then there's the floor of the tent. So we're going to consider each of those a plane, since it appears that they want you to refer to the picture. Okay, 9.
Okay.
9 says how many, or name 3 points that are collinear. So collinear means that they are on the same line. So there's actually only a couple options here. A, H, and B, they're on the same line. It looks like this in the figure, A, H, and B. And then F, J, and B, oops, went a little too far there. F, comma, J, comma, B, they are also on the same line. Okay, so 10 says, are the points coplanar? Coplanar. So coplanar means they're on the same plane. They have to be on the same sheet. So we have A, H, J, and D. They are not. So like A, H, A is here in the corner, H is here, and J is here. That's fine. J is there, but D is kind of down here. It's not part of it. So the answer is no.
Okay.
B, D, and F. B, D, and F are coplanar because they all form on this triangle that's in the back there. There's B, there's D, and there's F. They're all on the same flat surface. You can think of it as. Okay, I'm glad we got those last few questions in. Just a reminder about that homework help. Be a great option to get some of your questions answered. And I look forward to helping you next time. Thanks so much.